All right, so I think we'll get started. I'm Steve Garrity. I'm a PM on the .NET Services team, and I spend a lot of my day debugging stuff like this.
That was quick. I'm
Nice and easy.
Mark Gilbert. Just some quick background about myself. I've been at Microsoft about 9 years. I've worked on developer tools for quite a while. I was doing some service incubation stuff. I worked in search for a bit. And now I'm actually a technical assistant. And as part of that, I spend a lot of time looking at services, how we're running services, and really the technologies and just best practices for getting services running and going.
So now I feel the need to add to my introduction. I used to work for Mark, so we actually worked on search together. I spent a little while on Mesh, and then now work on the .NET Services platform.
Cool. So today, let's hop in, because we have a fair amount to cover, and we want to leave some time for Q&A. This is the obligatory service platform slide. Today, we're actually kind of covering not the specifics. We do drive into it in a few spots, but really just generally as a whole, how do we run services? How do we do all of these things? Kind of the magic behind some of it, a lot of the pitfalls behind some of it. The goal today is by 2:15, which is an hour from now, you'll hopefully understand, if you don't already, that scale-out async debugging really isn't easy. We're going to talk about the 5 stages of a running or dying service and how to keep your service in the former as opposed to the latter, if possible. And the way we're going to do that, because Steve and I really both learn best by lessons and stories, is really just to tell you a lot of the stories that we've hit, dumb things we've done, things that seemed really smart, why they weren't, and really how to avoid them yourself. And that's kind of what we're trying to do today. It's day 3 of the PDC. The press has all gone home. So we can now start to kind of show you under the covers of, some of the baling wire. And,
The duct tape.
Yeah, and that's what we're going to do today.
So the first question, we kind of want to motivate the talk a little bit, is why is this hard? Everybody's used to debugging. Everybody's built a lot of software here, you're all developers. And so we look at it and say, hey, what we're used to is sort of what we call the old life. And it's the kind of the client life. Everything's single-threaded. Right? You get to multi-threaded stuff, and you know how much harder it gets to debug when you're multi-threaded. You do have, when you're debugging kind of client-side software, one consistent view of the world. Right? You can look at all the state. It's on your machine. You've got access to the box. Anything you want to play with, you can play with. You might not have sources for all the libraries that you're using, but you do have access to everything that you're actually trying to debug. If you're really hardcore, you're going to attach a debugger. You might actually use .NET Reflector or something like that, and you can actually look at stuff you might not even have full access to. You can actually stop the program and debug. Setting a breakpoint isn't a big deal on your local box. And you can kind of see every piece of the system. If you have a SQL database laying somewhere else, but it's in your enterprise, you probably still have access to that box. In the new world, we've got sort of a parallel set of things here, and they're all less favorable to us as we're debugging. You end up in the state where everything is probably asynchronous. And if you've got a scale-out service, you're talking hundreds or thousands of machines. It gets much harder to start attaching a debugger. You don't have a really consistent view of the state of the system, right? That machine over there might think that something's true. This machine here actually already saw the event go by, which says it's false. You don't really have a good way of displaying to yourself what every machine thinks. Even if you could display it all and know all of it on a single machine, you wouldn't be able to parse it. We do have a lot of controlled access, at least the way that we run our systems and the way that most people run systems at scale. Not everybody has admin on everything, right? We built a lot of systems, as an example, on top of the SQL data services. I don't have admin on the SDS boxes for very good reason, right? I'm going to go in and start reconfiguring stuff. Oh, it'd be great if I could just fix that. No, it doesn't work that way. I can't access that stuff. The service also has to stay up. It's a live site, and you have users using it. And so going in and setting a breakpoint, not a good idea. We'll tell you some stories about that. And finally, there's a bunch of stuff, I kind of talked about this earlier with access. You just don't have visibility into how systems work if you don't own them. So we're going to kind of foreshadow a talk that comes after us, ironically. It's a great talk to go check out. Sriram from the Windows Azure team is going to tell about basically best practices for building a cloud service. If we'd scheduled this, we would have actually had you learn about how to build it and then how to debug it. But we did it the other way around, kind of just for fun and to test you. And so we're going to try to recap his entire talk in one slide. So I'm going to talk really fast. Pay attention. We have this model of an app, and we think that if you squint hard enough, you can map your app onto it, if it's a big distributed system. Right? You've kind of got some front-end roles. It's all scale-out. There's a lot of boxes there. You've got some back-end stuff. You might have a couple of different role instances in there. But you've seen this kind of happen before, and you've separated out all of your machines into different roles. This machine does that. That machine does this. You've got some dependent services on the back end. And the way that we like to talk about this is when you first start building your system, you're like, oh, I don't have a lot of value I can provide because I just started writing code. So all I'm going to do is take somebody else's service and reformat the results and give it to somebody else. Mark and I have done this a couple times. Got a lot of credit for doing it. And then finally, you probably got some stateful store of your own, right? You start adding some user content. You want to keep track of some things. There's some storage system. Hopefully, you're building on top of a scale-out store that already exists. Maybe for some reason you have to build your own. You kind of seen all these pieces. And so we're going to refer to the kind of a service that looks like this as we go forward in the talk.
Cool. So 3 of the things that we just want to cover quickly on this point, because it's important because we use the terms throughout the talk. And again, ESO3 will actually explain these things to you in detail. One is the notion of when we say a scale-out service, we have an assumption that any given node can fail at any time, and that thing has to be able to come back up and know where it is and actually do something valuable. The second one is the notion of a role. You've probably heard this in a lot of talks right now, but if you haven't, an application, if you take something like search as an example, is broken into roles. So we have a web front end, we have a crawler, we have the large index, we have a logging role. And so your application is built in, is kind of separated into these things. And then underneath the role is a role instance, which is like one, think of it as really one machine running that thing. And so as an example, as you'd imagine in something like search, we actually have a lot of machines crawling. So the role is the crawler. The role instance is any one of those crawlers at any given time.
So now we're going to go live. And we've built this service. That was the fastest demo you've ever seen. We built an entire service from the ground up. We flipped the switch. It's live to customers. And we're going to talk about what kind of starts to happen. And Mark and I have both made this observation, and we don't claim that it's original, but we've both seen it happen a couple times. When you build a new service and you flip the switch and you think you're about ready to go, you kind of enter this cycle. And until you get really comfortable with this cycle, and this is kind of basically the problem-solving and debugging cycle of services, your service isn't running particularly well just yet. And in our experience, it usually takes on the order of 6 months for a new team to get up and running and say, hey, we think we're going to go live. And then 6 months later, you're really where you thought you were going to be. And so we're going to kind of walk through. And the only way we found to solve this problem or to speed it up at all is to have made these mistakes before or to have known somebody who's made these mistakes. And then you can get through it quicker because you'll recognize it and see it and say, oh, I can fix that very fast, as opposed to learning it yourself. So let's see the cycle. So we've launched. Our service is up and running. You're probably getting a bunch of TechCrunch press. Everybody's hitting it. You're loving it. It's like, oh, this is really fun. And then something goes wrong. We don't know what that thing is, but it's a problem. And all of a sudden, we're getting reports. So there's something in the system that's gotten sort of not right. And I guess the first point we want to talk about is, how do you know that something broke? Did you get reports that it was breaking? Kind of where did that happen? So Mark, you've built a lot of monitoring systems. How'd the first one go?
So the first time we did this, and in fact, this was with Steve, we were in search building up this large system. And we were pretty excited. You know, we had built the thing. You know, for anyone who's shipped products before, it's a pretty exciting time. You're ready to go live. And we built this monitoring system because, you know, we were diligent throughout the whole thing. And we did what everyone does. We say, OK, look, we have a bunch of machines on the front end and back end. We're going to monitor those. I want to make sure the disks aren't full. I want to make sure the CPU isn't getting hammered, you know, those types of things. And I'm kind of reading these things. And then we were dependent on other services in search, specifically for local search results. So we would ping in occasionally and be like, hey, I hope you're up too. And if you're not, we're going to get a message because, you know, our service is pretty useless without that back end. So we did this. We were pretty excited about it. And then we went and basically, you know, turned the thing on, got everyone excited about it, got some stuff on TechCrunch. You know, blogs start to chat about search. We were actually doing a lot of mobile search stuff at this time. And we're feeling good about it. And, you know, we go in and check our monitors, and our CPUs are sitting around 4 or 5%, not really sure what they're even doing with that. You know, the disks are, frankly, kind of empty because we got a lot of disks. And we're thinking, all right, things are good, things are good. And then you start reading the blogs, and, you know, and you start looking at the feedback aliases and loops, and all of a sudden, customers are having problems. And we're like, oh, that's kind of weird. And you dismiss the first few thinking, like, random weird thing. And as time goes on, we start to realize that, you know, a lot of basic things are actually having problems from a customer point of view, and yet we have no idea about it in our monitoring system. So, you know, we're in Redmond. A lot of our first initial usage is in Seattle. People are searching for coffee shops in Seattle and getting 0 results, which is a big flag for anybody who's ever been to Seattle because there's quite a few coffee shops. And so we started looking at it, and we're like, huh, you know, that's kind of odd. And then we look, and we're like, the search service is up. And it turns out as we dig into this thing that 2 things had happened for us. One is that we were pinging the search service, and it was saying, yep, you're fine. Turns out that search is designed to stay up no matter what, which makes sense because that's, you know, their goal and their job. And so when they're either getting overloaded or something's going wrong, they'll just return 0 results to you. And it's a very well-formatted 0 results. The servers, the front-end servers that they have are answering. Everybody's happy about it, but you're getting no results back. And so we go and talk to them about this, and they're like, yep, that's what you got to get. You should really be monitoring that you're getting results back, not that, that we're alive, because those machines are always alive. And frankly, it's the load balancers that are responding to your pings. And we're like, oh, OK. Second of all, so we go through and change this, and we're like, hey, we're still getting 0 search results, and I'm pretty sure there's some coffee shops in Seattle. And then they look into it, and they realize, like, hey, when you're monitoring us, turns out you're tripping out our DOS filters. And we're like, oh. Why is that? And they're like, well, you spin up a bunch of threads on different machines monitoring the search service, and to us, that looks like a denial of service attack. So, our load balancers blocked you out, and all of a sudden, you're getting 0 search results on everything because, we think you're bad. And that made us kind of think, and we're like, OK, that's kind of interesting. And there's really kind of 2 big things that we pulled out of this. One at the start was that, monitoring isn't just the data that you're getting out of the operations center or any of these things. It's essentially the collection of data of everything we got from forms. And if we weren't actually checking on the forms, if we weren't talking to customers, I don't know when we actually would have understood that there was a problem. And so it's actually the mixture of all of these things, all the way from customers through to IT data, through to anything else, you using it, you dog fooding your own service, that really makes up the full sense of what we view as monitoring. And it's important that you hit a broad variety of these. The second thing is that there's different stacks of, in the monitoring. At the start, what I described, we had a bunch of operational level monitoring. Our CPUs were running fine, the networks existed, and the disks were all humming away because they weren't doing a whole lot. And at the top level, we had a few of our program managers kind of skimming the top, talking to customers, which is where we started to get these signs. And after we did this, you realize that across the stack for monitoring, it's very critical that you actually are monitoring not only at every level, but that you're really putting your emphasis on the top level. And if your service is running, kind of to the search example, and they're getting and it's working, your customers are happy, and that's OK. And if some of your CPUs are gunning it, you kind of want to know why that is and look into it. But all in all, things are OK. Similarly, if what the user is experiencing is horrible, but your operational level or your service level, system level monitors are fine, it really doesn't matter because your service isn't running and you have troubles that way. So that's basically how we look at monitoring.
So I think we decided we were going to take some notes for everybody just to make this deck a little more complete. So we're going to go ahead and take some notes. So what were your top couple of things you want to keep track of here?
So the real essence for us in monitoring is monitoring is all data about your service. The second one is to monitor really what the user sees and knows. And the third one that you'll see again and again as we go through this whole system is to be nice to your friends. And in this case, we basically had done a DOS attack on the core search engine. They thankfully had systems up to block us out. But most services that you see that you build out today have dependencies, or other people are dependent on you. And it's critical as you go through these systems that you can't really do any of this in isolation, and you need to talk with them. It's really the difference between being in a distributed system and a single program where you have a whole view of the world.
So that sounds good. So now that we've started monitoring, what should we talk about next?
So let's hop into diagnosing. So we know that there's a problem. We found out, we finally have our monitors fixed, and our users are having problems. And the challenge now is that you really need to start diagnosing what the heck's going on. You're in a data center, this is hard. There's really 2 ways this can go. If you do a good job at diagnosing, you get to move on to the next step of the cycle. If you do a bad job at diagnosing, you end up with this all-night frustration fest where you're basically sitting around trying to figure out what the heck's going on, and you really don't have the data. So the diagnosing is a key part. And now, Steve, why don't you tell us some of the challenges that you've had diagnosing services?
So I think the first one we built together. So back on the search service we were building, we sat down and we said, hey, we need a bunch of logging. Everybody's told us, you can't do this stuff in production. You got to log. You're going to have a lot of log data. You can comb through it. We said, hey, so we have a bunch of data. We want to analyze it. It makes really a lot of sense to put it in a database. And so we fired up our Visual Studio and said, hey, we're going to actually build a logging system that drops straight into the database. We have all these fancy tools. We have SQL analytics. We can do all this really cool stuff. So we're going to log to the database. So we started log in, and we're getting a bunch of data, and this is really cool. And we're smart. We looked at it and said, hey, we don't want to block writes and sort of block our customers as they're going through, so we're going to do it all asynchronously. So we'll fire stuff off to the database and just kind of wait for it to hit, and that's fine. And it worked great. We were checking and everything. Search results were coming back really quickly, and we got more and more load, and we started to see sort of a performance hit. And we said, oh, what's going on here? We were really careful about the async stuff. We're looking at it like our disk queues aren't too long. There's nothing kind of wacky going on there. And so, Mark, do you remember where we decided to log this data?
I think we ended up logging it to the database that was on the same disk where all the other data was coming from, if I remember.
That was it. So we had this database sitting there, and we're like, hey, we kind of need a database to log to. And so we're just going to throw it in this database. That can't go wrong, right? It can, because as we're reading and trying to get user data, we started slowing down. And so we learned our lesson, and we kind of said, that's probably a bad place to log data. And so then I went on to Mesh, and about a year later, and we started building a new logging system. And Mesh kind of got it right. We had a team of people building it, and we said, hey, we're going to disk. We're not going to do any of this messing around with databases and stuff like that. It's a really nice log system. It logs to local disk, so it's fast. We got a sort of collector service in the back that can sweep everything into a machine where we can analyze it. We can get it down into our sort of local machines and not keep it in the data center. And so the logging is working really, really well. Then we started building a rather complex part of the system. And so we said, hey, we want to log a lot of data. There's a really complicated state machine here. Let's just kind of when in doubt, we're going to log. We have this really fast logging system. We've tested it. We've made sure we're not bottlenecking. Let's log and log and log and log. And so we started logging, and that was great, and everything's going pretty well. And we got to the point where we were trying to troubleshoot the system. And we got a report that, hey, like earlier today, this thing was acting up on this one machine. Went to look at the logs, and there were only 10 minutes worth of logs. I mean, that's kind of strange. And we went and talked to the logging guys, and they said, well, we wanted to make sure we never filled up the disk. And so we rolled our logs. And so you can only have on the order of 100 megs of logs on disk at one time, because we don't want to keep more than that. You clearly don't want to take your system down because you ran out of disk space. We said, oh, 100 megs, that's a lot of logs. These are just text files. And we looked at it, and we actually set up so much logging that we were logging 10 megs a minute. And we're just going like nuts, right, and going crazy. So we said, oh, that's another mistake. And so we said, okay, well, we've built in the tracing levels and everything. We can just adjust the config and fix the bugs. And that kind of worked. And so that's kind of the how we're logging.
What about what you log? Because I know we hit some problems with this a few times.
That's another good question. So kind of how we log, and we've got some pretty good logging systems now. We've learned our lessons. And we're talking about what we should log. And we say, hey, we're in search, and so we really want to be able to kind of look at what our users are doing. So we had two kind of data points we wanted to get. We wanted to say, how many times are people using the service? So it's mobile. Are they using the service once a day on their phones? Are they using it twice a day? Are they using it once a week? And so we have sort of a unique ID and log that, and that's all fine. And then we want to know what people are searching for. And so we're going to log search queries. And we started thinking about it. We're like, that's actually a really bad idea, right? We've all heard about this, and there's a bunch of personally identifiable information. You don't want to log kind of who's searching and what they're searching for. So we didn't do that. Right? That's kind of bad. And so we logged just part of the search terms. And that was working fine. And we're like, we're truncating it. We're keeping track of everybody's privacy, and we're being really careful about that. And we hit another bug. And so somebody started saying, hey, and I think it actually might have been the one you were talking about earlier, certain set of searches aren't working. And we said, oh, we're going to go back through our logs, and we're going to start looking at these logs, and we're going to try to replay them. Because we have all the data you're searching for in all your requests, right? Turns out we didn't. We were so careful about it, and that was probably a good thing. We didn't actually have enough data to replay these requests. And so our users are saying, hey, our requests aren't working. And we're saying, well, in the logs, we see a bunch of requests, and they look like they're working. You can't really test them, though. Cool. So we sort of learned from that we didn't end up basically needing replayable logs.
So let me dive into that just a little bit. So what Steve was describing was the notion that we need, we need to be able to replay the logs. This is because of the great PDC template, 3 separate logs. The first one is really what we started with. When you start off, you're thinking, I'm going to log everything, man. And that's kind of to Steve's, 10-minute window story. If you're not going to use the data, you probably shouldn't log the data. And you can log a lot of data, and you're probably never going to be able to mine it out anyways. So you kind of got to watch what you want to do. But we started off and we said, hey, there's a unique idea of a user coming in. For anybody running a service, you'll generally know that you want to track how you're doing. One of those things is how many unique users you have. Are they coming back to the service? All of these types of things. So you give them a unique ID. The next thing is what they're searching for. Everyone always logs the time that the search came in. I don't really know why we do that exactly, but it's pretty cool.
It seemed useful.
Yeah, and then the response time. And we're like, hey, this thing came back in 0.05 seconds. We're feeling pretty good about that. Then, our privacy people came and talked to us, and they're like, we really don't want to be storing private information about these things. And so we looked at it, and we're like, okay, well, what we'll do is we really do want to know if people are coming back to our site. So we'll keep the unique ID. we actually didn't throw away the search term. We took the first 5 letters of the search that was going in just so you could understand that. And that, and then we did the time and the response time coming out of that as well. And this is literally what we went live with, and we were feeling pretty good about it. And the reality is, as soon as we got into the next stage, we realized we had no data that was actually useful to replay where we were. And so after a few months, we ended up with the bottom log, which is a replayable log that you can correlate and actually monitors the results. And it plays into monitoring as well. So you can see that, every time something came in, we did a search term, the time, a correlation ID, which is just a number we made up. But since it's a distributed system, every request needs to essentially be able to get tracked at some level through the systems. Your only hope of doing that is giving every request an ID, and as you pass it back to other parts of the system, to keep that thing current so you can actually start to correlate time. Anybody who's done a lot of even multi-process debugging on a machine or multi-app or multi-machine debugging, you understand very quickly that you can't get a synchronous clock across all of these machines, and you really need to just start getting in to the lines, understanding how all these different things connect and what they do with each other. The second thing we learned, which you can see in the bottom ones, is that at the start of the log, a request would come in, we'd remember it would go back out, and we'd write it in the log. The problem is that when things are going wrong, the request doesn't always go back out the other end. It never gets into the log, and now you've logged all the successful requests and not the bad ones. So then we got into the mode of saying, look, we're going to log everything. A search comes in, 4 to Seattle, 640, I'm going to give you a unique ID. And then the other thing you'll notice is a node ID, which is into the notion of roles and role instances. You actually need to figure out exactly which machine was behaving this way, because when you find problems, you often will start to see it isolated on one box at the start, either because it's running out of memory, it's the one that got pegged up to a certain CPU utilization or something, and you need to be able to quickly look at the logs and throw out everything that's not that machine. And then when the results come back, we can say, hey, there's 5 search results, because we learned very painfully from the last lesson that you need to know how many search results are coming back, not just that it responded, the time it came back, the unique ID. And then you'll also see, because it's a distributed system, that we have other responses. So we get things like how many ads came back and those types of things. And with the bottom log, it's actually very easy, as you'll see in the next steps, to start replaying and starting to debug your system and really filling it out that way. So in the spirit of taking notes, I think I can take these ones, Steve.
All right.
Logging done right, there's really 3 lessons for us. One is, replay your logs. If you can't take that data and make a fake existing system and relive it, it's kind of like replaying a debugger. You're really in trouble, and the logs are actually not very useful to you. The second one is correlate, which I can't spell, but I'll do this, and it'll probably fix it. Correlate your requests. And that's really, you're in a distributed system. Go PowerPoint. You're on a distributed system. The only way to actually line these things up is to start to correlate the things. And then the third one is there is too much of a good thing. And this is really, watch what you're logging. Be thoughtful. People even told us this before we went live, of like, only log what you need. Everyone logs everything at the start. You can never even get the data out of the system. And it's very true. Is there anything else for logging?
I think the other one we wanted to emphasize was first do no harm.
Oh, yes. That was
the Hippocratic oath of logging. This is data for when your system fails. Don't cause your system to fail.
And yeah, it's funny how, at times when systems start to come down, the logging and monitoring system are the ones that bring it down in a kind of weird,
kind of funny
way.
Exactly.
All right, so we got through logging. Oh, we need a word from our sponsors. So I'll take this one. So Windows Azure, CTP went out 2 days ago. We're very excited about it. We use it a lot. Everything we've been talking about is really on a general system level service. Anyone writing a service, you should use these practices and think about it. When you look at having a massive scale out service, logging and actually getting all your logs into one place and being able to manage them is a very important thing to do. If you are on Azure doing these things, there are logging APIs that they put into the base fabric for you, where you can essentially log across all of your machines. And then whenever you find a problem, and it's a rolling log, so it'll essentially keep some, but not forever. And whenever you find a problem, you can actually go to the portal, hit the button, and they'll dump all the logs automatically for you into the store. Sriram's actually giving that demo in the next talk that should have been before this talk, but we're keeping you on your toes if you want to see that. But it's actually very, very valuable. It's one of those things that the platform is doing, trying to abstract for you so that not all of us need to go home and write a scale-out logging system, which is actually kind of important. Similarly,
a word from my favorite sponsor. We've got another cool trick that we learned as we were building a bunch of this stuff. And I don't know how many people have seen .NET Services, the service bus. which is our sort of message relay infrastructure. We learned a pretty fun trick as we were building a bunch of these systems, and we used the service bus internally for some things, where we'd say, hey, we're going to use a multicast service bus, and we're going to save ourselves some time and not actually show you writing the code, but I'll explain the concept. And it's basically, hey, if I'm sending messages back and forth between a bunch of services and I'm using multicast, I can actually plug in another listener on the fly. And so I can kind of have a channel of messages going between two machines, and I can say, hey, something's going wrong with this thing. I don't always want to be logging it because there's some overhead associated with it. But I can basically flip on it's essentially a tap, right? And I can say, hey, since I control this channel, I can actually add another listener to it and grab those messages and log them. And now I've got a log stream which I can keep kind of careful control of, and I only take, for example, the perf hit or the disk space hit or whatever I want when I really know I need it, but it lets me react to logging pretty carefully. All right, so we've got our systems monitored. We've diagnosed the problem. We kind of have a rough idea of where this is. And so now we need to actually go figure out how to fix this thing. And so, as Mark was saying earlier, each one of these steps as we go through the cycle has sort of two possible outcomes. If you do it right and you do it wrong. And so in sort of the fix and the validating your fix part, either way you're going to get to a fix, and you're going to say, hey, let's deploy it to the live site. And if the fix is good and you validated it successfully and carefully, you're going to deploy and you're going to kind of go back to the fun state and everything works well. If you accidentally deploy a bad fix or even deploy the fix wrong, you end up just causing more problems. And so you can get into this state where you now have the original problem that you're trying to fix, but you've caused two other problems in the middle of fixing it. So, Mark, why is it actually much harder to sort of debug and fix a problem in a distributed system than what we normally think of?
It's a good question, Steve. So fixing, as we've talked about earlier, all of the normal tools we have around debugging, being able to lock the entire system and move parts of it forward at a time, getting an entire view of the whole state of the system, these things don't really happen in the services world, unfortunately. And it's a very challenging thing to start to understand how you actually go about debugging these things when you have a problem. The key things in monitoring was to find that you had a problem. In diagnosing is really about gathering as much information as you can for the fix stage. And when you get to the fix stage, this is really when you understand whether you've done the first two steps properly or not. And so I remember actually the first time we pushed a service live and everything was going well. And after we got a lot of our search problems fixed, we actually had a problem. One of the machines was dying. It was clearly a software bug. It was 99.9% chance our software bug. We couldn't really figure out what to do. And so we sat there nervously, and I remember this very specifically because I didn't sleep for the next few days, and I sweat more than I probably sweat throughout the course of a year in these days. And the problem was that these machines and operations were having problems, and we really couldn't figure out or try to even understand how to start debugging these machines. And so what I did, and just for clarity, for anyone running in operations normally, operations will normally be a separate security entity that it runs in. You do not have access to get into these things directly. Obviously, as you're getting your system up for the first time, you work closely with your operations people, and they're really part of the team. And so you kind of learn a few of the admin passwords that you could get out of these guys that you're not supposed to have. They take about a month to reset them, so you have this sliding window. And so I did what, honestly, I think everyone does, is I went back to my desk, I lifted up my keyboard, where I had the Post-it note of the admin login to get into the data center. So I go in, and for us, we essentially have to tunnel into our data center. You get on a machine there, and then from that, you can go attach to another machine. And I was at least, I would say, I don't know, smart enough or lucky enough or whatever to tell the operations guys I was doing this. And kind of like, hey, guys, we got to do this, blah, 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 blah. And they were like, well, OK, if you're going to do this, we'll at least bring your role instance out of rotation. And right there, I was impressed that our operations people had actually thought through the fact that there are some machines running in operations that you need to be able to pull out of rotation at any time. And so they did this for us. They reprogrammed the load balancers to get this thing out. It was a very painful thing to go do, but they realized that we had kind of backed ourselves into a bad corner, and we go do it. So then you go and you basically attach a debugger and you start debugging this thing. The problem you have now is that not only is that server down, and as we know, some bugs are quick to fix, some take days and days and days. And the other challenge is that the other systems that you're talking with are actually now blocked out from you because you've been moved out of rotation. And for a variety of networking issues, it's actually very hard for you to get there or do anything about it. And so we really got stuck. And I'd like to say that we figured out a good solution to this problem. But what we did is we do what we normally do at Microsoft. We go to the guys who have done this before, and we ask them how to do it. And so they told us, and they said, look, there's two things you need to do when you're fixing and validating problems. Assuming you have replayable logs and all of these things, and this is always hard to hear after you've developed a product, there are things you have to do while you're developing your product to make this stage work. Of course, we had not done those because we were very excited about shipping the product. But the two were role isolation and one box, are really what we call them. Role isolation, to give you an idea, as Steve mentioned, every service has a set of roles. One of the things you learn quickly, which is essentially what the operations team did for me, was they pulled my role out of circulation and did it. You actually realize that you need to be able to take a role, put it on a machine that you can debug on, which generally will be your dev machine, and as part of that, fake all of the other interactions with them. So in this case, on our Squint and your service looks like this architecture, if you pull out the back end, we actually have to have the logs to be able to feed into the back end fake requests, which again is why logging is so critical. We have to be able to issue fake requests to the service dependencies and get fake answers back. And we have to have some access to the store and be able to do that. And so this actually takes a lot of work when you're developing your services to make sure that you can always, that you're actually, separated enough where you can pull out and essentially fake little, stubs for all the other roles. And you actually have to write these stubs, and you got to keep them up to date. And the challenge that we always had was that, you're rushing to get the thing out. You're very excited. This is the easy thing to cut because you're always thinking, my service will run. I'll be fine. And it takes dev time to actually keep these things in sync. But being able to do role isolation and replay on your box is critical. And if you don't do it, basically in your primary time, you're going to have problems, and you won't be able to debug your problems after. The second one, which is equally as important, if not more, and you've seen this, it's funny because this is one of these things where, when we started doing the services platform, Azure, a few years ago, all of the teams started up and just started running. And they were all at kind of different phases. Some of them were already been going for a bit not. And in the normal Microsoft way, we don't talk for the first year. We all just have our heads down. We're hammering away. Everyone's very excited. And one of the things that everyone came back with after the first year was their one-box solution. Nobody had mentioned it. Nobody had said anything about it. But what happens is that you realize every service, and if you look at ours, the .NET services, SQL services, Windows, Azure, all of these actually have a one-box deploy where you can run the entire system on one box. It's not super simple to do. You have to do a lot of dev work to get it that way. But the idea is that you can actually take all of your roles, ideally fit them in like 4 to 8 gigs of RAM, jam them on a box and run it. And for those kind of really heinous bugs where, it is a correlation problem, this thing is tripping this thing because this answers 5 times, this thing's getting overloaded, the only way to do it is really to go through to do the full, to get the full service running on a single box and run that. And it may sound fairly easy to do this, but you realize that when you're designing all of these things to be scale out from the start, you build a system that really is designed to be running on many, many machines at a minimum, and it's kind of challenging to fit it on one box. And so as an example, one of the services that we did, in fact, Bob showed it during the keynote on the first day, the System Center Atlanta stuff, which I'm helping out with now. In that one, we've actually had to go through and we wrote in Astoria head end, or we took the Astoria head end, put it on SQL, wrote something on it so it looked exactly like SSDS does for us. We took the front end and the back end and got them onto the same boxes. And then we're dependent on a back end channel with the .NET services. And so we have both the ability to take the .NET services one box deployment and put it on, which is nice because we work at Microsoft. But similarly, we actually have a number of other plugs that you can use to fake out the .NET services and really give it a one-box thing. The challenge with this is every time we go to make progress on other features, you have to keep all of those systems up to date so that when the things go to crap, you actually have an ability to go in and debug it. And that's basically the one box for us. So let me just try to summarize that quick and talk about fix and validate done right. The two big things here are obviously, as I mentioned, role isolation and one box. You even hear the one box term. It's funny at the PDC as we talk to different teams doing services, you'll start to kind of hear them leaking these things and talking about it. And the reality is I can pretty much assure you, even search, all of these systems can run on one box that this devs sit and they start running that way. So these are really the two critical tools that we didn't even learn. We actually just cheated and asked. Apparently Control F5 and Shift F5 do not do the same thing in PowerPoint. Just side note.
We're debugging on the fly.
So that's basically how we learned about fix and validate. And after fix and validate, I was responsible for slide animation, so I apologize. After fix and validate, we get to the deploy stage. And the deploy stage normally is easy, because in the box product world, the deploy stage is does your setup work. It's easy to test separately. It's easy to do all these things.
Who thinks setup is easy? Anybody ever written a box setup installer? It's easier.
easier. So Steve, I'm gonna pop back to you, and you're gonna explain to us why deploying is hard and all of the things we need to do about it.
All right, great. So, and this is kind of the same thing we talked about earlier with the fix step, where if your deployment goes well, then everything's happy and you're kind of back to a good state and you're just kind of waiting for the next problem. If your deployment goes poorly and you can't recover from that, you end up in a bad state again. So I think the first thing we wanted to talk about was why deployment is hard in general, right? And so again, when you're deploying something in a service, there's a tendency to say, hey, I'm setting this up. I can do some things manually, right? And when you're doing a box software install, you know you're not going to ask your customer to take a bunch of steps, right? And say, hey, okay, can you tweak this reg setting? Can you do this? Can you do that? You kind of know you're going to automate it. And as Mark said, that's pretty straightforward to test, right? You can kind of build it, you test it, it works or it doesn't. Yeah, there's some edge cases around on that config or whatever, but you can test it pretty easily. In this case, when you're deploying and you get on a release rhythm, and we always talk about how services move faster, you may be deploying once a week or once every 2 weeks or once every month. You really need it to be fully automated. If you don't, you end up with this script that looks something like this. And it basically starts off with, hey, run this install script. And then, oh, make sure you enter creds for that thing. And then don't forget you need to install that cert over there. And please configure this URL here. And you get to kind of a game of Jenga. And at some point, somebody pulls the wrong brick and it topples over. And we've done this a couple times, as you can imagine. And so this is actually a hard problem to get right. So I think the first thing we're going to talk about is, the next thing we're going to talk about is some assumptions that we make. Everybody kind of gets these as this is important. So it's fully automated. We kind of just talked about why that's important. We also talk about how you need to be version compatible, both forwards and backwards. This seems like kind of an obvious thing. You have a big data center. Everybody kind of sees immediately. You can't just roll it all at once, right? You're going to have 1,000 machines. You're going to have to upgrade 20 at a time, something like that. So you need this version compatibility. We're kind of making these assumptions about your deployment system already. And finally, that you can do, with the versioning, rolling upgrades. And so you can actually do scale unit by scale unit upgrades. And you can also say, if an upgrade fails, for whatever reason, could be a bad machine, could be a bug in your code, could have just been something random that we don't understand yet, you can roll it back, right? Because you don't want to get yourself in a stuck state where half your machines are now upgraded and are unusable to your customers. And so we're kind of making some assumptions about the deployment system to begin with. And I think from there, what do we have? So we'll talk about the queues in just a bit, but I guess we'll tell a couple stories first.
Some bad stories on deployment that we've had.
Yeah, we've never screwed up deployment, I promise. The first one, and actually this is where we'll get to the queue, is a couple of times that we've deployed and ended up DOSing other services. And so when you're building these large scalable systems, you'll realize that you want to queue a whole bunch of things. And you want to say, great, I know that parts of my system are going to go down. I know that this one role instance over here is kind of flaky right now, and I don't want that to propagate through the whole system. And so I'll queue requests to it. And if the system's down, I'm just going to hang out and wait and wait and wait. It'll come back up in a couple minutes, and I can process a bunch of stuff. This is something you really have to do, right? As you're building distributed systems, you just know there's some slack in the system, and you got to take that up. And so in a bunch of cases, we've been really good, and we've built queues into our system. And we're really happy, and it kind of goes and goes and goes. And the system goes down for 5 minutes, and it comes back up and recovers well. The problem is if you have a major outage. And so we've had a couple of times, and we did this on Mesh once, where we went down, and we were down for, and this was before we'd launched, but we were down in test environments for 12 hours, 24 hours. And we came back up, and only one part of our system was down. The queues kicked in, everything was great, and all of a sudden, here come 1 million login requests. Went off to Live ID. And the Live ID guys pretty quickly called and said, guys, that's not cool. We don't want to handle that right now. And so we realized, oops, we probably should have cleared those queues after we'd been down for quite that long. So we've goofed that up once. We had a separate issue, and it's sort of unrelated, but it's a fun deployment one, where we manually patched stuff. And we kind of violated our own rule, and we said, hey, we have these automated deployment problems. We had this bug in an earlier version of something, and the fix was, hey, we'll fix it for real in the next major deployment, but we can patch it for now. We're going to write a little background job, and it was effectively a cleanup bug. We weren't cleaning up some caches correctly. And so we're going to write a little background job that says, hey, let's go clean the caches manually, and then we'll fix it in the next version. And this worked really great. We deployed the script, and somebody set it up. Unfortunately, the operations guy who deployed it was signed on using his own credentials and not the service credentials. So he runs the job in the background. The job's running. His password expires. No problem. He goes and resets it. Forgets that the job was running under his credentials. And then a week later, the job hasn't been cleaning anything up. And we say, oops, that caused a bunch of problems. And now the service is down. We've got to go recover it. That'll teach us to deploy manually. And I think we got one more story here, but I'm blanking on it.
Yep.
Oh, yeah, there
I'll
we
take
go.
care of this one. So one of the other things, actually, it's funny because these stories that we talk about, we noticed Steve and I just even getting ready for this talk. It's easy for us to talk about things that we did 2 years ago that were very painful. We're a little more sensitive when it gets to things that happened very recently. And so obviously last week, before we did the Azure Services Platform, everything was running well. We were basically sitting around sipping coffee in Redmond watching the servers hum away. And as part of that, we had a large service patch go out last week and for Windows. And as part of this, we have a lot of servers now in operation because we're getting ready for this week, which is a very big week for us. And everyone kind of looks at it and like, hey, we got to patch every single one of our servers, which is well into the thousands on a lot of these things. So we look at this and we say, okay. And very quickly with this, kind of looping around in the whole talk, you can tell the teams that had kind of followed the guidance and had these automatic systems and the ones that hadn't. And so one of the teams that Steve works with very closely, so he doesn't like to tell these stories because they still kind of sting, because he didn't sleep for 2 days because of it, basically had like manually configured load balancers. And that all's fine. Everyone's happy with it. The whole system gets upgraded. One of their load balancers fails. And it just, from what we could tell, failed because it was time for it to fail. They roll it to the backup. And it actually ends up taking them 12 hours to kind of reverse engineer all of the different things they had done to the first load balancer, because the developers, the architects, and the operations people were just continually manually tweaking this thing. And by the end of it, we had no idea what state it was in when it was running, and we couldn't really replay or do anything else. And so literally that night, I don't think anybody slept. We're all sitting there getting emails every hour about what state this thing is in and going, and it just kind of reminded us of the value of this. And one of the largest ones we've had in this space, which I think we talk about, I'm pretty sure we talked about publicly, right? I know someone else did already, so I'm not going to get in trouble here. But a while ago, Live ID went down. I think it was about 2 years ago now. And a lot of the other services in Windows Live and MSN use Live ID. In fact, I think all of them do.
Basically.
And so it went down. And queues, everyone's using queues, and I'm going to talk a little bit more about that. But all these people are queuing up requests and queuing up requests and queuing up requests. And they're like, hey, if that thing's not responding, I'm just going to build it up and fire it off. And then so after 24 hours, because it was a fairly heinous challenge and problem they were having, they basically brought it back up. And at that point, we had 6 of our data centers with well into the tens of thousands of machines, all with queues that had been built up over the last day, just DOS and hammer the crap out of Live ID. And there was nothing they could do about it. They're just sitting there. And so in a really funny way, the operations people started going through and turning off all of our internal routers to prevent internal traffic, because that was the only way that our services can talk to each other, and only allow external traffic in. And the other problem is, obviously, when you've done one of these fixes, you're feeling good about it, you're excited. You don't really want to start off, with getting 50,000 hits in the first minute. You kind of want to warm it up, slide up the dial and be like, all right, it's working for 1. Look, we just did 10. We're up to 50. And so it's one of these challenges we have where, when you get these challenges, when you get these problems, it's always going to be one role that gets upgraded. You're never going to upgrade everything else at the same time because you have to stay running and you have too many services running, which is why you need compatibility. And then you get these issues where you really need to think about how you use queues. And queues specifically for people, the reason it's valuable to highlight is if you're writing a distributed system and you haven't really as much, you'll understand that you actually very quickly start to use queues. And we learn this. It's kind of in a scale-out world, it's just a very well-accepted way of handling failure, handling even consistency requirements between things. So as an example, if you have a scale-out website that it's important, it's always running, but isn't always reliable, and then you have a payment system, which is obviously very critical that it's very consistent, you put a queue in the middle of that. So if the payment system ever goes down, the queue builds up, and then when it comes back up, it goes. And as long as those things are reliably processed and you know very clearly if it did or didn't happen, essentially you're transacting it, you're good. And so we use queues for this. And Windows Azure, as you look at the bottom layer, you realize actually has a number of these capabilities built into it, because it's very valuable for you when you're writing these apps to build it. So they're very friendly, but as you can hear just from the stories we have, they actually can cause you an insane amount of problems if you don't clearly think through how you should use queues. And really, it's not just queues, it's how the roles interact in your system and how you deal with your dependencies as things come down and back up. Because everything is really designed to be running, And the reality is, even doing a rolling upgrade, you know that some things are going to stop running, and you have to stop connecting with specific servers and start, like load balancing around. So the key thing with queues is you really have to understand, do you throttle these things when they come back up or not? Because ultimately, if you have enough servers, and these are pretty nice servers that you end up having, and you throw out 1,000 of those things, and they all have a queue filled up with a bunch of requests to one service, it doesn't really matter what that thing is. It's going to come screaming down. The second one, which Steve mentioned earlier about, like holding up creds for live ID because mesh was down, is the data even still relevant? If you come up 2 hours later, do you need code in there to just clear that queue? Is it, and again, if it's a payment system, they probably are relevant and you want to throttle. If it's something like an auth, I doubt the guy's still hanging out at his browser waiting for live ID to respond and tell you that you're allowed to log in or not.
Our customers are that loyal.
Yeah. Some days we wish they were. And then the other one, which is a big one, is do your friends know what's going on, which is all the services that you're dependent on, all the services that depend on you. You actually have to sit down and look and model the way of, if they go down, what happens? If I go down, what happens? What if something they use go down? Because they will appear to still be up, but essentially be non-functional for you. And so these are kind of the critical things to think through around deploying and the way that we do those things.
There's one thing we forgot to talk about so far, and I've been trying to think of the whole talk of a good story for this, and I haven't come up with a really pretty entertaining one. So we'll talk about it anyways, and this is what we call managing your environments. And so if you look at the normal sort of evolution of a services team, you'll say, hey, we have one environment, and we're building our product in a test environment. We're deploying stuff into it, and we're kind of going. And you get to the point where you launch, and you say, hey, great, the test environment's now a live environment. It's been working really well, we're all set. You launch, and you're running, and you've probably thought ahead, and you're like, we need another place to test fixes, because something's going to go wrong with our live site. So you kind of spin up another environment next to it, and you got a test environment. And then you say, okay, great, we got this, we're doing our V2, we're going to roll out our V2, and then you realize you're building V3, and you have a problem with V2, but your test environment's being used for V3. So you need another environment. We often call this like the QFE environment or something, because you want to test your fixes in the data center, and you kind of go from there. And pretty quickly, you can kind of balloon, and I've seen teams that have 12, 14, 16 different environments used for kind of testing different things, right? And you get pretty big services teams, and you're managing integrations across source branches and all kinds of stuff you want to test. And so you end up with this huge proliferation of environments. And each environment means new IP addresses, new DNS records, new certs, new everything. Right? And I guess I should be really clear when I say environments, this is a full instance of a service. Right? So this is an entire instance of the .NET services or of Mesh or something else. And so you've got a bunch of environments, and you realize, oops, maybe we created just a few too many. And now you're trying to figure out and keep people on the same page as to, hey, what's this environment getting used for today? What's that environment getting used for? And so you start to develop a plan around it. And pretty quickly you get into this rhythm where you're saying, hey, okay, we have this integration environment that we use for this, and we're going to test kind of two components coming together. And we have a QFE environment when we're fixing the live site, and we obviously have prod. And then a bunch of devs say, hey, we actually want our own environments to test individual fixes before we actually deploy them. And so you probably have a sandbox environment, and we set these up, and we say, okay, anybody can deploy to these things. They're restricted. They might only be on the corporate network. And we've got all these environments, we're starting to manage them. And then you realize, and this is kind of the third evolution of services teams, you realize, well, I want to test this environment, and I want to try it for weeks and weeks and weeks before I launch. But I have a bunch of user data there, and in the live site, and it's my friends, and like, so Spaces or Hotmail would be a great example of this. I don't actually want to use a test cluster of Hotmail, because all my friends email me at my Hotmail address. And I can't email my friends from a test cluster, so how do I use this? And so you get to the point where you say, okay, well, now we're going to run multiple versions of the software accessing the same data store. And it gets more complicated. And I don't think we probably have time to dive into exactly how we do that. But we kind of wanted to call out the whole idea of environments takes some pretty careful planning. And once again, you'll save yourself a bunch of time by figuring this out ahead of time. And you can kind of predict it, you kind of can't, you learn as you go.
Sounds good. On to lessons. So what were your lessons of deploying? I don't know why.
So automation. It's all about automation. Everything, we kind of talked about why this breaks if we're not automated. I think the next one was knowing our environments. And making sure we get those kind of locked down the right way. And then I think the final one we wanted to talk about was be nice to your friends, or they might not talk to you anymore, or shut off their ACLs on their routers.
Yeah, it seems like everyone has a be nice to your friends every step. And on the environments, like the thing that was very interesting for me coming from the product world was, when you're building products every day, the way to think of an environment is, it's just a new build target. It's a build target, and it's probably something in your source control. So you always keep your BVTs, you have the daily build, you have the daily build that actually passed the tests, that the devs are running. Sometimes. You have the daily build, the last build that you actually gave out to other people in the company. You have the last build that went out publicly. And the way you manage all these things is really just, you're building to a different share with a different label, and you label the source so you can go back and find out what's going on. Even with that, it's a challenge and a bit of a pain in the butt. When you think of the service world, the challenge is that you actually need a large, environment for each of these. And how you manage those environments and run is actually very important. And again, as we look at things like Windows Azure and the functionality we have down there, they have built in the notion that you're in staging, and that you stage something and you try it out there, and then you just flip. And they don't actually move your software over. They just take your network and just flip it over and start pointing at the network beside it and going that way. And so the way you actually understand and work through these things is very critical. It's important that you think through it beforehand. Otherwise, you end up with a ton of servers that are expensive and you're actually getting not a whole lot of value out of. Cool. On we go.
All right. So when I kind of recap each one of these cycles of life. So monitoring, right? We've talked about all these, and we'll just kind of go back. And really, if you had to take one thing away about monitoring, the key is all you really care about is what your customers see, right? And Mark kind of talked about this, and we had a couple of problems early on where we said, hey, there's no problem. The CPUs are all looking great. And, well, the customers don't care about the CPU cycles. They care about what the results they're getting. And so really, it's hard to simulate this, right? The only way you can actually fully simulate this is sit there and try it. Use it and use it. No, it's kind of working how I expect. The closer you can get to automating that, and making it not manual, the better off you'll be. Mark, what about logging?
So, really the wrap on logging is you need to be able to replay your logs and correlate. They're distributed systems. And we say these things as if they're very trivial. It's actually hard to do this. And quite honestly, a lot of our services under the hood are getting into about 75% of this. The better ones are near 100. The worst ones are below 75%. Put it mildly. And then as we move on, investing in role isolation in one box. This is just, it's the equivalent of the debug build. In the on-premises world, you flip your compiler to debug, you hit go, and it goes fine. Anybody who's built a huge app, eventually that causes you problems because you have compiler bugs in the optimizer and stuff, and you need to keep them in sync. But ultimately, it's a fairly straightforward cost. It's very low cost. In the services world, given where we are right now, you just have to build these things out and make sure that they stay relevant. And then the last one for deploying is just know your environments. Understand what's going to happen as pieces come down and not, and basically to go that way.
So you basically save the best for last. And the one big takeaway is we were kind of sitting this morning at breakfast talking about kind of what we really wanted to sum up is the one thing from this talk. This is all still pretty early stage, right? We're all still learning here. And we don't claim to have all the answers. But what we found is we made a bunch of mistakes as we did this, and the only reason we didn't make the mistakes again is because we'd made the mistakes once. The only reason we didn't make a different set of even more basic mistakes is because we went and talked to a bunch of people who'd done it before and made those mistakes. And so if we have to encourage you to do one thing, I think it's basically just kind of ask around. It's basically tribal knowledge at this point, and we're working on making it better. And we kind of talked about how our sponsors are working on making this problem a little easier. And clearly we have a bunch of stuff in the works, and we're not going to promise you a bunch of stuff, but we have a bunch of stuff in the works to make these tools work better. But right now, a lot of it is go out, try some stuff, ask some people, share what you learned, laugh at yourself, and have fun.
Cool. And so I'm going to have two quick requests on the evals outside of just fill out your eval. One is for this talk, and we're going to do Q&A after this. For this talk, we specifically didn't, which is kind of a PDC no-no, show a lot of code or dive into it, because we thought building one of these debuggable systems would be kind of unruly and, to understand. A lot of these things are in the labs and the hands-on labs. But tell us in the evals, if you, as I mentioned, Steve and I learned very well from stories and the pain that we've gone through and we've heard other people go through. If this is helpful for you, let us know. If it's not, let us know as well so that we don't do these things again. And then the second one is that I think you guys have noticed that this is the first PDC ever, or frankly, Microsoft event where we're not forced to wear speaker shirts, not that they're ugly. So if everyone just puts a note in there saying, hey, we really like how you didn't force the speaker to wear speaker shirts because they look a lot more comfortable, that would be really fantastic as well. Cool. And if anybody has questions and answers, we can do some at the mics now. We're going to be around a bit after, too. Happy to talk about anything. I think we're just going to get people coming up because there's somebody leaving.
How's it going? Sure.
Do you have any scenarios where you have clusters to like a single database? Do you have ever run into that?
All the time. Should we turn off our mics? We use the mics and we'll try to repeat stuff when people are up here. That way everybody can hear. So the first question up here was, have we ever run into problems with lots of machines hitting the same database? Is that right? So yeah, so basically cluster stuff. We've run into a lot of performance problems, not so many debugging problems, because you have kind of a single point of truth, and that's interesting. But from a performance point of view, yeah, we run into problems with that all the time. And that's where you end up saying, yeah, you've got to move to sort of a scale-out model. And you're saying, okay, we're going to partition the database and actually shard stuff. We're going to have multiple databases that service different parts of the request. And the key there, sort of overly generalized, is you don't want to have a lookup table for anything, right? You can't actually assume you're going to be able to look up what data lives where. You've got to be able to drive it from the data. So hashing is the most common way of doing this. So yeah, that's probably one of the first bottlenecks you'll hit in terms of performance, because you can scale out your front ends no problem, and then your database in the back end is going to be very disk IO intensive and just topple before too long. So, yeah.
Steve?
Steve, there's a question here.
Hey, go ahead.
At what point are we going to be able to run everything local? I mean, the Azure Fabric and everything, the SQL data services, are we going to be able to run that on our local dev box? Or
so I'm actually not sure about some of them. I know some already have Dev Fabric.
Windows Azure.
Right, so Windows Azure actually has a Dev Fabric you can download and run locally and debug into that fabric. I don't know about SDS, or actually I don't know about .NET Services, what we're planning for that. The hard part with a lot of services is you should assume there are some parts of it you'll never be able to run locally.
Right.
For example, and I'll assert this, don't take this as an official position, I doubt that we'll ever provide a way to run Live ID fully locally. Right? That seems like just a bad idea from the kind of the stuff that Live ID does and a bunch of other things. And so you have to assume that parts of services debugging, you'll never actually be able to do it locally. And so then it's can you simulate it? Can you repro problems going into it? Exactly.
Just out of that too, because I've had a few kind of side questions. The key thing to this is that with Azure, I forget what the official branding name is, but the Azure One Box development deployment, I guess. You can run a lot of that system on your box and understand how it works. The Fabric controller, which is the kind of piece under that, is run locally, which helps immensely. Currently, right now, we don't have the capability to attach to the cloud per se and debug in that way. The Windows Azure team is very aware of trying to make it as easy as possible to debug and diagnose problems, because that's a lot of the value they believe they're bringing. So we expect that more and more stuff will come in there. But right now, you can at least pull that on premises. Really, for SSDS, what we do, what everyone honestly does internally even, is they use Astoria on top of SQL, and they build out an interface that looks the same. And they just, because one of the challenges with SSDS, or SDS, sorry, is your partitioning and data layout. You basically just force yourself to stay in that same data partitioning on the local box. And the .NET services, because they connect and with WCF and things like that, you can emulate a lot of those things locally, but you don't have the actual relays and these types of things on your dev box, right? Which is one of the challenges.
Yeah. You can imagine basically building, for the data store in particular, a data adapter layer. And this is actually what we do in .NET Services, and it's actually how Mesh does it as well, where you've got an adapter that basically exposes your object model, and underneath you don't really care what it's stored in. Obviously, some are higher scale than others, but so when we run it locally in a dev box, it's SQL, like Mark said, and I know Atlanta does this as well.
Yeah.
When you run it in the cloud, you're obviously using Windows Azure storage or the SQL Data Services storage.
Cool. How they actually run under the hood Azure?
Staging and switching from one.
The next ESO3.
There's a few
Should talk about
sessions.
some of that.
Some of them. ESO3 is definitely a good one to hit. There's actually a
that.
SQL data services under the hood that Gopal's doing tomorrow morning, I believe.
Yeah.
He talks about how they roll out, which is frankly one of the most complex, just because it's consistent state across the whole world. How they do that and how they manage it and how they roll out. Yeah, and a lot of it's just best practices and pay and learn. And I think there's actually one on messaging as well that Clemens was doing.
Yeah, Clemens is doing one, I think at 3 o'clock actually.
Okay, on that as well. So those are kind of best practices from what they've learned and and how they're designed underneath it. I don't believe we actually have a deep how you do this on Azure. Do you know what I mean? Which is one of the tricks.
Exactly.
We all know what we mean. Are there any other questions for the mics? Or?
So do we have anything like remote debugging or debugging on the server that?
So with Azure right now, we don't have debugging, like what we would call debugging in the cloud or attaching to the cloud. They have a local dev fabric. The only real difference between the local dev fabric and the one in the cloud is that they're not running the virtualization layer on the local dev fabric because it's fairly resource intensive. But the way that we actually have gotten around that, honestly, is we're using Hyper-V on our dev boxes, and then we basically build in VS and then run the Red Dog fabric in a virtualized box just to make sure that we're not pulling anything out of like the state out of our dev boxes. And run that way. And they allow you to spin up multiple instances. So you test all the load balancing. All of those things actually get validated very easily. You can see how you deploy in that. They'll spin up backend instances. And they even have the storage service running locally as well. So you can basically get to that, like in a very specific storage service running that they basically sit on top of SQL doing it, but it gives you the same behavior that they have. So you can get pretty far along. Yeah, the trick is, as always, this is like, the analogy I use, having come from there, is device debugging. Whenever you're emulating something, the closer and closer we get the emulator to the reality, the better. The problem is that those few problems that you have left in those cracks are really pretty doozy. And that's where, honestly, the logging, like Azure's logging, is probably the most critical thing. Kind of getting to what Steve and I are talking about, is that it's almost it's assumed that the logic in your code has gotten figured out and debugged before you even push your stuff up to the cloud. The trick is once you're actually running in the cloud, how do you start, figuring out what the heck's going on when things go wrong?
That's actually probably the best point is you can get a lot of your issues out locally. There are some issues that will only repro across 100 machines. Yeah. Right? You're only going to hit, like we've had this a couple times with our services, where you're hitting kind of a really subtle race condition. Right? And it only really manifests itself when you've got 100 or 1,000 machines trying to do something at once. Okay. And so that one, and you can imagine, once you're running your own VMs in the sky, like if you actually had a full VM that you're running, you might be able to get access to that and debug on that. Right. But you'll never be able to debug exactly, save an image. You can never debug the layer underneath. Like you'll never actually be able to attach to our data center machines from a security point of view. Yep. And so it's how do you log enough stuff that you can replay it locally and figure out the bug without actually having to have a debugger.
Okay, thank you.
Thanks.
Cool.
That was actually part of my question, was designing for replayability and for correlations, because some of it is, I know that when you want to do correlation, you have to sometimes tunnel this correlation ID across different things, like for a session or an operation. I was just wondering, do you have any resources on how to design for replayability?
Yeah, we don't have anything else here, Eric, but so there's a few things with this. One of the big challenges, we mentioned the logging part about having a correlation ID. Mm-hmm. That's easy if you have if you own all the hops, because you can just pass the correlation ID around. One of the other things that you start to see coming out in some of the service stuffs is just like, in the good old Windows days where I would basically create a function, I would pass it a blob, and that function would call me back with that blob, and I could put whatever the heck I wanted in that. We start to see some things where we actually pass those things around, and they'll just take things to be able to correlate. One of the biggest challenges, though, are really the two with correlation. One is that when you go through a system that's opaque, that you don't own, how do you keep that thing going? And there's some tricks, but it really depends on the system you're talking with. And then the second one is when you have fan out. So when we hit search, what search does is it basically takes a query and fans it out to anywhere between 3 and 8 different systems. One is the search results, one is local search, one is ads, one is instant answers, one is the logging system. And those things come back at different times, and the way that system works is it kind of waits for the search results and maybe a bit longer. But after that, it's like, I got to respond back because I don't want to hold up this connection on this because of the scale they have. And so, this is why if you hit reload and search all the time, you'll actually start to see that parts of your screen are redrawing on any of the search engines because they all work this way. And it's very hard to then log and correlate because you don't know why that fifth system didn't answer or why it took 3 minutes to answer because your main response has already gone back. So those are, there's not a great thing. People have done kind of the tree notion where you have a correlation ID and then everyone appends their little stuff. To it where you could kind of build a tree out of it. The problem in that is that we really don't have the tools built out to suck that data out and build it visually. You kind of imagine in your head what you want to get, but it's hard to get it because there's just a lot of data.
We actually have a running joke internally that some of the guys behind you will get. That basically, the people who are the best at reading these log files, it literally looks like the Matrix, right? Because you can imagine these log files are just scrolling and scrolling, and it's GUID. And you kind of get used to recognizing stuff, and as you read enough of them, you're parsing out, and you're like, oh, really all I need is the first 4 bytes, and you can kind of correlate stuff. we still don't have the tools built in a really good way yet to let you do this stuff automatically or visually, like Mark said.
Cool. Thanks, Eric.
Yes.
Yeah, so the question was, do we have a standard logging framework? As mentioned, Windows Azure has a fantastic logging framework in it. It abstracts out a variety of things. So when Steve talked about how to log, it just handles how to log for you. And you think it'd be easy, but there's actually a lot of bad ways to log. And then the other thing it does is it aggregates. So if you have 5 roles in your app and each one has 10 instances running, you can basically log on each of those blobs, and it will aggregate out, and whenever you want, it'll basically take that and dump it into the store, into, I don't know what we call Xstore publicly, but the store that they have.
That now.
That thing, yeah.
Windows Azure
Windows
storage.
Azure Store. We're still getting used to the branding. And basically, so it'll dump to that, and then it also provides you a window so that you can basically just log to this thing freely, like for eternity, and it will just throw out bad data on the back end. So to give you an idea, for us, we will generally have, just to get, if you're starting a new service to get something up on your own, you probably have 2 developers for about 3 months writing a logging system that just puts to the right machines, correlates to somehow, pulls it back, and that's before you've done any real reporting outside of the big, console dump.
The easy stuff.
The
other one that you see that's pretty nice that we've plugged into in some other cases where we're not using that system, system.diagnostics in the .NET framework has a nice pluggable model for trace listeners where you can basically plug in sources and sinks effectively. And so you can say, hey, I want to write this event, write this event, write this event. If nobody's listening, it's just a no-op. It just throws it away real fast and performantly. And then you can plug in a listener in config that says, hey, I want this saved to the event log. I want this saved to the file. And here's the filter I want you to apply. So there's actually a pretty nice framework there.
Problem with, we actually moved from their to log from a logging file to the database, async, exactly what you told before. Because the risk listener doesn't release the file. You can't delete the file. And it comes growing into
you can actually, you can build your own sources?
Oh,
Oh, yeah, sorry. So he was just asking about, it's the same question as before, which is basically, what systems would you use for logging? So saying that the trace listener, and your point was, trace listener doesn't release the file underneath the covers. You can build your own file sync that will actually handle that correctly and roll logs and stuff like that. But there's a fair amount of code to do that.
Cool. Anything else?
Yeah, hi. Concerning the deployment experience, is it currently possible to push something from a continuous integration server directly to the staging stage? Do you provide this kind of scenario?
We don't. So the way it works with Azure is you build and you package locally and run. You then take that package and you basically cab it up and push it up. So you basically take that package and you go. So you can take the same build and push it up, but it won't dynamically swap for you. So when you go in Azure, when you go from staging to release, what it does, literally, we mentioned this, is that it brings up a number of services, a number of role instances for you in staging, and then you already have a bunch running in release, and those are running well. And the load balancer just points at release.
Yeah, but I was not talking about the scenario from staging to prod, but more from the development environment.
Right. So from staging to prod, you get the flip. That it's literally just a network switch. You don't have that from prod. I mean, you don't have that from development. Development, you have to push up and you have to deploy to staging.
Do you have any meaning to automate?
I think what you're asking is there an API to push bits into staging?
MS build
and I don't think there's one yet. Although I think it's probably relatively straightforward if you look at it. I think it's in the plans. It's in the plans.
Yeah, it is. So right now you have to use the portal. You will very soon have you will soon have a programmatic interface to do that directly.
Okay. To basically build.
But right now you are on the load up your browser.
Okay, thanks.
Old school, we call it.
So if you talk about staging, is there some kind of events I have to respond to if I go to staging from one version to the next? So I'm doing upgrade and downgrade to provide rollback?
So the question was, what kind of events do you have to respond to when you're doing upgrades and staging to production? And it's not really so much events. It's just the way that we think about it. You need to know that you're going to have old customers coming in over your old protocols. So if you're just a website, it might not be that bad. If you have a programmatic interface and you're changing that, you've got your new bits that are getting rolled out have to be able to respond to both old and new versions. I guess there's another story we didn't tell where we've broken this before. where if you have automatic rollbacks going on, and so we use a system internally that does basically watchdogs that will monitor our systems and say, hey, if this thing starts failing, I want you to roll back this scale unit to a previous build, because clearly the deployment's in the process of failing. We've done it before where we didn't upgrade the watchdogs first, and so you roll out a new build, and you say, and the version N watchdog is hitting the version N+1 service and failing for a good reason, right? And it says, oops, deployment failed. I'm going to roll that back to version N. So there's oftentimes an order that you have to upgrade pieces in. You can also imagine things like you need to upgrade your database schema first, and then your data needs to get migrated before you can ever talk to it using new protocols. So there's an ordering, and it's hard to, I'm not going to be able to give a consistent, here's the pattern for building that ordering, but you have to think through it. But it's not really an event programming model. It's actually just a way you think about which part of the system you roll out at which point. It's quite, it's quite difficult.
To give you an idea as well, just as like a tidbit of knowledge, one of our largest services on the machine front spends about 20% of its network bandwidth just doing rollbacks and push-ups of upgrades. Because, and the way they do it is that when they deploy their new service, they always keep the old service on the box, because the ability to like upgrade that many machines without a problem across that many roles, they hit a lot and they need to be able to immediately roll back for scale reasons. And so they basically will copy the same two things to the same box, run the new one, and if they start to hit problems, they just send a message to all of them, and they all flip back to run the old one, and then they slowly start erasing the new one and trying to get the old, like it's this long process. But you really do need to plan for it, because the amount of times you actually need to like kind of move forward through the, like as you said, different stages of staging and then come back and move forward it's quite a lot. You do it a lot. And normally in the services world, you're shipping more than, once a year kind of thing. Quite a bit more.
Ryan? Oh, sorry.
Yes.
Yeah. Well, yeah, they better know them.
Great talk. Thank you very much. I'm not sure if this is the right venue for this one, but the APIs you all provide for Fabric and storage, that kind of thing, when you have non-backward compatible changes to those, how are you going to handle them? Can Azure services say, I'm using this API version, or?
That's a good question. So it depends on which part of the framework you talk about. I actually don't have a particularly good answer for Windows Azure. I'm just not familiar enough with it. My assumption is that you'll be able to differentiate versions in your package. Because if you think about it, most of the APIs you provide at that point are for the package that you upload. Right. For .NET services, we have some version stuff built in already. There'll be more coming.
There'll be service lifetime and some sunsetting like anything.
Exactly.
Right.
Yeah, we're generally aware the need to keep service consistency up for quite a while is something that, and that's one of the things as we move to release that will become much more locked down.
Good practice to raise your version every before you do.
Yeah, so the question is it a good practice to raise your version? Yeah, like even in box software, everything is slightly different. And you often end up in a model where one role is in a certain version, one role is on like a .0011, It's because as you take fixes into a service, you only will really put them into the areas that you need them. You obviously aren't going to just push everything out new because the rest of it's working quite well. And you're thankful about that. So yeah, so you almost always end up in a hybrid world where you end up with like a bunch of, dot releases.
You look at it the same way as box software with the major, minor, build, and .build numbers. Yeah. We just tend to increment. We do it the same way we do with normal builds.
Yeah. It's like if you look at your version numbers and all your Windows DLLs, they're not all the same all the time. But anyways. Okay.
Really?
Speak to the Azure service
model. So the question is, can we speak to the Azure service model? You mean the ones that we support now with the front end, the back end, and the store and the queue?
Whose neck do we show? Because we think there's something going on in Azure space.
Oh, in the sense of like service support. Now, how do we have that?
Nothing goes wrong, ever.
Yeah, it'll all just run. It'll run fine. So right now, that team's doing a lot on. In fact, you should, ESO3, the talk that's starting soon. I would go ask them. But that team's doing a lot to essentially do manual, like a lot of just like, hey, we're checking forms, we're doing all these things to get feedback. They will get. They are working hard to get a kind of a purely automated system so that you can see more about what's going on underneath. And their goal, quite honestly, is for you to be able to serve it yourself, right? And so they can tell you this is doing this, and you're like, I don't want that, I want this. Yeah. You can do those things. Ultimately, also, as we get towards release, we'll have more, offerings targeted towards businesses that need to run, that want one neck to choke, one person to call that can actually go through and do those things.
Paid
And so
support
those will
models or
build
whatever
up
it is,
too, but we won't have them definitely in the CTP phase. We'll probably start rolling them out in beta. Our goal is to have go live licenses sometime in the beta phase for people, and at that point we need them. I'm not sure actually what their rollout, what they've announced or plans.
I don't know if we've,
but
yeah.
There you go. It's officially unknown at this point, but I can tell you they're working hard for it. Any other questions?
I hope you gave your experience to the SharePoint development team. Managing a SharePoint farm is a real thing today.
Yeah, the SharePoint guys have gotten a lot of. They're like, SharePoint Online is them hosting SharePoint, and they've done a lot of changes just running on that and the challenge they've had.
It's actually been really fun to watch as people run their enterprise software and we start moving those types of services towards the cloud. Everything that people have learned doing that.
Yeah, it is kind of funny to watch. It's good. Cool. Well, thanks again for everyone.